4.1 number 38, trying to find the critical points and determine the local extreme values. So first thing we have to do is find the derivative. You can distribute the x to the 2/3 if you wanted to, or you could do a product rule. Maybe I'll distribute. Never thought of that. So y equals 2 2/3, so that's 8/3. Oops, x to the 8/3 minus 4x to the 2/3. So my derivative is 8/3 x to the 5/3 minus 8/3 x to the negative 1/3. Maybe I'll just leave it as 1/3 power. Okay, so we can find the derivative. We found the derivative set equal to 0. So I'll add that. Multiply by 3x to the 1/3. X to the 5/3 times x to the 1/3 is x to the 6/3, or x squared. So x squared equals 1. So x equals plus or minus 1. In plus or minus 1, both of those are part of the domain. You can do any of the domain would be all real numbers. Okay, so we have horizontal tangent at 1 and negative 1. So critical points so far we've got negative 1 and 1. Looking at the derivative here, what's going to make the bottom 0? Well, that's 0. It's undefined. So 0 is another potential extrema. Okay, so we have all of our x values. Now we can just look at the graph. Okay, so this all makes sense. We've got a horizontal tangent negative 1 at 1, and we have an undefined derivative at 0, which does produce a local max. So our three critical points are negative 1 comma, let's figure out what that is. Calculate value, so that's negative 3. It looks like it's going to be an even function, but just to confirm, 1 should be, yes, it is also negative 3. So negative 1, 3, 1, 3 are both absolute mins. And at 0, if I calculate 0, it's also 0. And that's a local max. The best way to write this, like this would all be acceptable. Even better would be an absolute min is equal to, oh, that's negative 3. Add x equals plus or minus 1, and we have a local max equal to 0 at x equals 0.